Okay, let's talk about vector function. Okay, so like x and y is notated in parametric equation form. Then we're gonna try to make it as the Cartesian form, and we will draw the graph of this one too. Okay, so here we go. First of all, let me write as the system form 2t minus 1 and my y is equal to 2 minus t. And we're gonna do the substitution method, okay? Here we go. Let me solve for t for the first equation, then plus 1 on both sides, and divide by 2 on both sides. Then it will be your t is equal to 1/2 x plus 1/2. Then what I'm gonna do is I'm gonna plug in this one into second equation, okay, into t. Then your second equation will be the equation between x and y. Y is equal to 2 minus, instead of t, we're going to use 1/2 x plus 1/2. Okay, let me solve for slope intercept form. Then this is y is equal to negative 1/2 x and plus 3/2. Is that okay? So this is your Cartesian form of the equation, okay? So now let's talk about the graph of this one, okay? So look at that. In this problem, you have the range for the parameter t. It changed from 2 to 2, right? So when you plug in -2, then you can get an x and y point, okay? When you plug in t equal 2, then you can find another point. And then that is exactly two endpoint of your line, okay? As you can see, this Cartesian form, that is the linear equation form, okay? It is straight line, okay? So first of all, let me plug in t is equal to -2. Then your x is equal to 2 times -2 minus 1, which is -5. And your y is 2 minus -2. And double minus, which is plus, right, is 4. So your first point is -5, 4. Okay? And what about the other point? When t is equal to, okay, then my x is 2 times 2 minus 1, which is 3. And my y point, y component of point is 2 minus 2, which is 0. So your second point is 3, 0. Is that okay so far? So, okay. In x, y plane, my first point is -5, 4. Let's say this is -5. Somewhere here is 4. This point, okay? Since there is, in your interval, since there is equal sign, and this point will be inclusive, okay? What about second point? 3, 0. 3 is somewhere here. And this point, it is also inclusive. So your straight line is like that, okay? But one more thing. So look at the problem. They said your parameter is increasing, okay? So in another word, which means your t is moving this way. Does it make sense? Which means your point is moving this way too, from -5, 4 to 3, 0. So this is the direction of motion, okay? Let me give you another example, okay? So we will do same thing, okay? Substitution, okay? So, okay, here we go. Let me rewrite this one. My x is 2t minus 1, and my y is t squared minus 1. Okay, I love to use the system form, okay? And we will try to solve for t for the first equation, then plus 1 on both sides. Then it is x plus 1 equal to 2t, right? And divide by 2 on both sides. Then finally, my t can be written in terms of x. And then, as we did it before, and I'm gonna plug in this one into my second equation. It's really clear and easy process, right? Then my second equation will be equation of x and y only, okay? Y is equal to, instead of t, it will be x plus 1 over 2 squared and minus 1. okay? So here, let me try to do a little bit like, technical, okay? This square is working for numerator and denominator separately, okay? So I can write this one as x plus 1 square and 2 square denominator, which is 4, okay? So finally, like, it might better to write this one as 1/4 times x plus 1 square minus 1. Look at that. Do you remember this equation? That is this function, okay? That is the quadratic function, okay? And we know the graph of this, okay? If you have positive coefficient from x squared, it will be smiley face, okay? If you have negative sign, it will be sad face, okay? So this case definitely smiley face, okay? And also with this form, we say this is the vertex form, so which means we can easily find the vertex of this quadratic equation, okay? So the vertex is -1, -1, okay? So this -1 came from this part, okay? You just try to make this one equal to 0, okay? Then once this is equal to 0, then your y value equal to -1. That's why your vertex is -1, -1, okay? So now, what about the graph of this one? It is definitely smiley face, and the vertex is -1, -1. Is okay? So here we go. Oh, before doing that one, like in this problem, since your parameter t is increasing, we're going to choose like two different t value to see the, like, the direction of motion, okay? There we go. So first of all, let me decide, you can choose any number, okay? But let me decide t equal to 0. Then my x is 2 times 0 minus 1, which is -1. That is my x component. And my y component is 0 squared minus 1, which is -1. So my first point is -1, -1, okay? What about the other one? You can choose any number, but like for my convenience, let me choose 1, okay? Then my x component is 2 times 1 minus 1, which is equal to 1. And my y is 1 squared minus 1, which is equal to 0. Is okay? So like my second point is 1, 0. As we did before, like since t is increasing, like your point motion is this direction, okay? In other words, in an x and y, xy plane, it is moving this way, okay? So there we go. So now let me come back to the graph of function. So x and y, and my vertex is -1, -1. This is my vertex, and it will be smiley face. And we know one point is -1, -1, this point, but the other one is like 1, 0, maybe somewhere here. The my graph will be this kind of smiley face, okay? And also, like, since it's symmetric, and it will be like that, okay? And it is symmetric, okay? So let me talk about the, motion direction. First point, when t equals 0, it is here. Let me mark t equals 0, okay? When t is equal to parameter t equal to 1, and the point will be 1, 0, which is this point. When t is equal to 1, right? So like since your parameter t is increasing, your point is moving this direction, okay? Okay, let me give another example, but this is a little bit different with previous, okay? To take care of this problem, we have to know one important thing, which is the trigonometric identity. Do you remember that one? It is cosine square theta plus sine square theta equals 0, okay? So like for, since we're gonna use this one, let me make the note here, okay? So I believe you have to remember this one because this is important, okay? From your high school as well, okay? Here we go. Trigonometric identity, okay? Which is cosine square theta plus sine square theta equal to 1, okay? I believe we will have a chance to talk about this one with detail later, okay? But for now, let me use it, okay? So here we go. So as we did before, let me write this one as a system form. It's not necessary, but like I would love to, okay? 3 cosine theta, it is x. And my y is 4 sine theta. And then what are you going to do is we're going to solve for cosine and sine, which means we're going to divide by 3 for the first one. Then x over 3 is your cosine theta. Okay? And then for second one, we're going to divide by 4. Then this will be y over 4. That is your sine theta. Now, can you imagine, like, can you, like, connect with this one and that one? So we're going to plug in cosine and sine into here, which means like we're going to replace your cosine and sine with x over 3 and y over 4. Does it make sense? So then your trig identity will be written in terms of x and y. X over 3, which is cosine theta n squared. And this is like trigonometric notation. Cosine squared theta means cosine theta squared. Okay, that's why you have this, okay? And this one as well. Sine squared theta means sine theta n squared, okay? So this will be y over 4 n squared equal to 1. Okay, that's it. This is Cartesian form, okay? But do you know, like, what kind of like equation it is? It is ellipse. Okay, so like, the graph of ellipse is really easy. Since you have 3 on the bottom of x, that is concerned with your x-intercept. Okay, and this 4, that is definitely y-intercept. Does it make sense? Let me extend a little bit more. -4. So you have like this kind of football. Is that okay? So now we're going to talk about the motion of like, point on this graph, okay? So like since your parameter theta is increasing, we're going to choose like 2 different theta, okay? So for my computer, let me choose like first theta as 0 because that is easy to find like all the trig function value, okay? Then my x is, which is equal to 3 cosine theta, then cosine 0, okay? Do you remember cosine 0? Cosine 0 equal to 1. I already gave you the answer, right? It is 3. And my y, which is 4 sine theta, which is sine 0. Don't forget sine 0 equal to 0, okay? So that is equal to 0. So your first point at theta equals 0 is 3, 0, okay? Can you find it? Yes, you can do it. I'm talking about this point. When theta equal to 0, okay? Oh, I wrote 3. Sorry for bad writing, okay? And what about the other point? Okay, well, we can choose like theta equals 1, but like if you choose theta equals 1, then there's no way to evaluate cosine 1 and sine 1, okay? So for my computer, let me try to use like pi over 2, okay? So if I say my theta is pi over 2, which is 90 degrees, then my x is 3 cosine pi over 2. And don't forget, cosine pi over 2 equal to 0, okay? That is 0. And y is equal to 4 sine pi over 2. Okay, sine pi over 2 equal to 1, which is 4. So my next point is 0, 4. Definitely, it must be on the curve. I'm talking about this guy. When your theta equal to pi over 2, okay? Again, your parameter is changing this direction, okay, which is increasing, which means on the graph, your point is moving this way, okay? So from here to here. Does it make sense? Okay, we can say that this is counterclockwise. Is that okay?